In this video here, we're going to take a look at formulating linear programming problems. Now, we need to be able to formulate real-life problems as linear programming problems. And in the previous chapter, we covered this with two variable situations. So to formulate a linear programming problem, we start by defining our decision variables. We then write down the objective. And then finally, we write down the constraints. And in the next video, we will introduce something known as the simplex method, which allows us to solve linear programming problems with more than two variables. And this is particularly useful for, say, logistics companies and large online retailers to optimize their shipping and distribution networks. And in this chapter, we will consider more complicated linear programming problems. So, before we take a look at formulating linear programming problems, we do need to be aware then that we can transform inequalities into equations by using something known as slack variables. So let's take a look then at how we can do that. So like we just said then, let's just take a quick look here at how we can convert inequalities into equations by using slack variables. Now it is often easier to implement an algorithm using systems of equations rather than systems of inequalities. And we can transform inequalities into equations by using slack variables. So for example then, let's say that we want to rewrite the following inequality here. So x1 plus 2x2 plus 4x3 is less than or equal to 15. So as an equation using the slack variable r, this would simply be x1 plus 2x2 plus 4x3 plus r. So we add the slack variable and then we change the inequality to an equation. Okay, like you can see, pretty straightforward. Now the value of the slack variable r tells us by how much x1 plus 2x2 plus 4x3 is less than 15. So therefore r is equal to 15 minus x1 minus 2x2 minus 4x3. So as you can see then, the whole concept here of going from inequalities to equations by using slack variables is pretty straightforward. So to finish with here then, let's just work through an example together. So let's just get started here then with this practice question. So what we've got here then for this question is the constraints for a linear programming problem, and they're given as follows. So as we can see here, then we've got a system of inequalities, right? So for example, then I've got 2x1 plus 4x2 plus 3x3 plus 6x4 is less than or equal to 50. That is my first constraint there. For the next constraint, I've got 10x1 plus 8x2 plus 12x3 plus so on and so on. I won't bother reading out each individual constraint, but you get the idea. Now for this question then, all we want to do here is rewrite the constraints as a system of equations by using these slack variables, okay? That gives you a big clue here, right? If we're going from a system of inequalities to a system of equations, the only way that we can do that is by introducing some slack variables, right? And we're given here r, s, t, and u, okay? So where do we begin here? So it's actually pretty straightforward. If I want to go, for example, from my first constraint here as an inequality to an equation, all I need to do here is write down these again. So 2x1 plus 4x2 plus 3x3 plus 6x4. We then introduce one of the slack variables. So I'll just go from left to right here, right? So I'm going to introduce r as my first slack variable. And then we change the inequality to an equation. That's all we simply need to do here. It's pretty straightforward. So to get us started then, like we just said here, we've got 2x1. So 2x1 plus 4x2 plus 3x3 plus 6x4. We now introduce one of the slack variables. So I'm going to introduce r here as my slack variable. So plus r. And again, as we just mentioned before, change the inequality now to an equation. So this here then is equal to 50. Perfect. Nice and easy, right? And we just repeat this process now for each individual constraint. So moving on then, the next line here, I get 10x1. So 10x1 plus 8x2 plus 12x3 plus 9x4. We now introduce one of the slack variables here. So the next one is s, so plus s. And this here then is equal to 240. Good stuff. Moving on then, the next one here, I get 16x1. So 16x1 plus 20x2. So 20x2 plus 24x3 plus 18x4 plus 18x4. Again, we need to introduce one of these select variables here, so plus t. So plus t, and this here then is equal to 360. Perfect. Let's just keep going here. So for the next line then, I get 20x1, 20x1 plus 30x2. So 30x2 plus 25x3. So 25x3 plus 20x4. So 20x4. Don't forget, we do also need a select variable here as well. So plus u, the final select variable. So plus u there. And this here then is equal to 400. Perfect. Okay. But be slightly careful here. We're not finished at this point because we also need to include the non-negativity condition here, or this constraint. So x1, x2, x3, and x4 all must be positive. Okay. But be slightly careful here because select variables, generally speaking, cannot be negative as well. So for my non-negativity constraint or condition here, I also need to include the select variables as well. So underneath then, what I'm going to get here is x1, x2, x3, x4. And like we just said then, we also include the select variables here. So r, s, t, and u, all of these here must be greater than or equal to 0 as well. Okay, it would have looked a little bit neater if I kind of shifted this to the left here, but it doesn't matter too much. I'm just being a little bit pedantic there. But there we have it then. So that gives us the solution here to the one practice question for this video here. And that brings us to the end then of this video here on formulating linear programming problems.